So in our network model, the first layer we saw was the physical layer. The next one, in the physical layer we had bits. The next layer was data link. In the data link layer we had created frames to give some structure to the endless stream of zeros and ones. In the third layer was the network layer. In the network layer we created packets. So now the data link layer allowed us to connect two machines directly together, exchange data in the form of frames, using the addresses which are 48-bit addresses that are hard-coded into the network interface cards, the MAC addresses. With the network layer, it allowed us to route packets through distant networks with many hops in between, and these packets use special unique addresses that are unique for all machines part of those networks or the internet, called IP addresses. However, in this layer, there was no guarantee that the packets will make it. And in order to provide guarantee, we needed the transport layer, because in the transport layer we create these segments which will use a port number and a socket to establish connections between client and server, or sender and receiver. And through these connections, it allows us to track all the bits and pieces of the packets that is sent between sender and receiver, and if anything is missing, it allows to retransmit it and then place it in the correct order if it arrives out of order. So it allows us to sequence or track the packets, which are called segments in this case. And the next topmost layer in our model is the application layer. And the application layer, we do not have any particular data unit such as frame or packet or segment, because we have many protocols and applications that use their own type of data unit which reside in this layer. So we call this an application layer data unit. And in the top of our network model, process, which is a running program that needs to use the network, directly interacts with the application layer. So let's think, what kind of, so it will interact with the application layer, and the application layer, when it gets the data that needs to be sent, it passes it down to the transport layer, to the network, to the data link, to the physical, until it gets on the physical wire or through the air and reaches the destination machine. Now, what kind of users or applications need to use the network? So let's think about the application layer now. In this layer, all the applications are found. Can you think of an example application that needs to use the network?
FaceTime.
FaceTime.
Yes.
Is that what you said? Okay, FaceTime is an application
any online video game ever.
Okay, online video game, he says.
Snapchat, Yu-Gi-Oh.
Anything involving media of any sort?
Okay, he said YouTube. YouTube. Media which what? Which has to be sent over the network, right? Because obviously we can have a video downloaded on our laptop and watching that media does not need to use the network. How about any of the applications on your cell phone? How many applications on the cell phone need to use the network?
Pretty much all of them.
Oh, pretty good percent. I don't know, maybe 90, not more than 90%.
Man, that calculator just eats up data. Yeah, if you take all the outside you have that take up the network, the calculator makes less than 1%.
Calculator
Yeah, it's on my phone.
does not need to use the network, even though it's on the cell phone. But for the most part, most of the applications need to use the network. Whatever in the world that application is, it resides in the application layer, and that's why we have this layer. It allows any of these applications to send requests through the network. So we have a bunch of protocols that they need to use in order to do that. Remember, the protocols were just a set of rules that the communicating parties will use in order to make the communication happen or to make it possible. So a protocol is a set of rules that the parties will agree to follow in order to communicate. Example protocols in this layer will be think of some example protocols in this layer. One example protocol is Telnet. So Telnet allows us to remotely connect to another machine and run commands on that machine through the command line. Another example here is the file transfer protocol, FTP. That's an application layer protocol. So certain application will use this protocol to communicate to another application through the network for transferring files. So if we want to upload or download files to a server, then we will follow this file transfer protocol, which is an application layer protocol. Other protocols very popular here.
HTTP.
Look in your browser.
HTTP.
What does it say? Yeah. What does it say in the URL? How does the URL start? It says http:// and then whatever, google.com. So HTTP is the Hypertext Transfer Protocol, which is an application layer protocol that which applications need to use? The browser. The browser needs this protocol that is the set of rules that it follows in order to talk to the web server. So that's an application layer data unit. That's how browsers talk to web servers. So that's one protocol that exists here. Can you think of others for this layer?
It should be S.
Okay, HTTPS is what? The secure HTTP. So it is used for communication between client and server, which is browser and web server, which is encrypted. That is an application layer protocol. Let's think of another example.
SSH.
Okay, SSH. So very good.
LDAP. LDAP.
Okay, LDAP. How about email? What if we want to send and receive email? What protocol does the email client have to use to communicate with an email server?
Or SMTP.
SMTP.
Very good. So SMTP is what? Simple mail transfer. Simple mail transfer protocol. And there is a bunch of others that go with it, such as IMAP and POP3 and a bunch of others which are used for email clients to submit emails and to get emails off of the email server or to receive emails. And probably a very important one. Oh, how about a protocol that the internet service provider would use to assign IP addresses to its clients?
DNS.
Do you know what that is? So we said that in the network layer, every machine here that wants to be part of the network has to have a unique address called the IP address. How does it get this IP address? We mentioned that there is an international organization that is managing all the IP addresses in the world. And then if we are an internet service provider, we will obtain a bunch of these IP addresses and sell it to home users or businesses or other organizations that want to be on the internet. So imagine we are an internet service provider. We obtain just like a couple of million IP addresses that we want to give out to our customers so they will be connected to the internet. How are we going to do that?
Well,
one option is to go and just pick the first address, assign it to the first person, write it down on the table, pick the next address.
Well, but you have to look at the network. I mean, how big is the ISP? Is the ISP over in the city? Because then the network is, the network's not that big, but if it's over America, an entire continent, now I want to group IP addresses based on geographical location.
Yeah, so one option is to manually assign the addresses, or we can dynamically assign the addresses. And if we do that, we have a protocol for that called the Dynamic Host Configuration Protocol, DHCP. And this is what the internet service providers would use to assign the IP addresses. And the reason they do that is because, okay, we obtained 1 million addresses, but we have 2 million customers. Can we play some kind of a game to serve 2 million customers with 1 million addresses?
Only static IP address is possible.
What if the person is not at home, but they're working all day long? They're not using the address. We'll just take it from them and give it to somebody else for the time period. And the DHCP allows us to do that. So this also means that the next time we want to connect to the internet, we will get a different IP address than the one we had yesterday, which is kind of an issue if we want to run a server, for example. Say, we want to run an FTP server on our home machine, so we want to be able to access our files at home at any time from anywhere. So we need to run an FTP server at home. Well, how are we going to connect to the server? Well, we need the IP address to connect to the server to establish the TCP connection. And all of a sudden, the internet service provider just changed our IP address because they gave it to somebody else because they were not at home 5 hours ago. So the address keeps changing like that because it's dynamically assigned. So if we want to have a static address that never changes, then we can request that from the internet service provider, but they're going to charge us a bunch of more money for that than what we would normally pay them. And the reason being is that they're trying to serve as many customers as possible with whatever addresses that they do have. And another very important protocol here, I'll ask you to look into your browser one more time and tell me what you see. You see HTTP : // and what does follow after that?
www.
www dot.
URL.
Dot what? What are you looking at? Google, I don't know. What do you have open up there? What is that? That's a URL, right? That's a uniform resource locator. Okay. So an important protocol, I'll say, that allows us to have these URLs is the domain name system. That is also an application layer sitting in the application layer.